Hello, all. Welcome to the day 16 of the daily case study series for Cbse grade 12. The question goes like this: if two vectors are represented by the two sides of a triangle taken in order, then their sum is represented by the third side of the triangle taken in opposite order, and this is known as the triangle law of vector addition. It's true. Based on the above information, answer the following questions. If P vector, Q vector, R vector represents the sides of a triangle taken in order, then Q plus R is. So let's consider this triangle ABC. Let this be P vector, Q vector, and R vector. Let's mark the direction of the vectors. AB vector plus BC vector is equal to AC vector. Q vector plus BC is R vector is equal to minus CA, which is equal to minus P. So the option is C. Second subdivision: if ABCD is a parallelogram and AC and BD are its diagonals, then AC plus BD is equal to. In triangle ABC, AC vector is equal to AB vector plus BC vector. Let this be equation 1. And in triangle BCD, BD vector is equal to BC vector plus CD vector. Adding both the equations, we get AC plus BD is equal to AB vector plus BC vector plus BC vector plus CD vector. AB vector plus 2BC plus CD vector has the same magnitude as AB, but just the direction is different. So let's write this as minus AB. So we get the answer as 2 times BC vector. So the option is C. Third subdivision: if ABCD is a parallelogram where AB is equal to 2A vector and BC is equal to 2B vector, then AC minus BD is equal to. AC vector minus BD vector is equal to AC. We know we have taken it in the previous subdivision. AC is AB plus BC minus BD is the equation 2 in the previous subdivision, which is BC plus CD. Opening the bracket, we get AB vector plus BC vector minus BC vector minus CD vector. BC and BC goes away. AB, CD is just opposite of AB. So this can be written as minus of minus AB. So it becomes 2AB vector. AB vector is given by 2A, which is equal to 4A vector. So the option is B. Subdivision 4. If ABCD is a quadrilateral whose diagonals are AC vector and BD vector, then BA plus CD is equal to. From equation 1, we get AC is equal to AB vector plus BC vector. AC vector is equal to, because the question is asking for BA, I am rewriting this AB in BA form, so which is minus BA plus BC vector. So from here, BA vector is equal to BC vector minus AC vector. Let's name this as 3. Then from equation 2, we have BD is equal to BC plus CD. From here, let's take CD. CD is equal to BD vector minus BC vector. Let's name this as 4. Adding the equations 3 and 4, we get BA vector plus CD vector is equal to BC vector minus AC vector plus BD vector minus BC vector. So in this, BC vector minus BC vector goes away. The remaining is minus AC vector plus BD vector, which can be written as CA vector plus BD vector. So the option is D. Subdivision 5. If T is the midpoint of the side YZ of the triangle XYZ, then find XY vector plus XZ vector. In triangle XTY, XY vector is equal to XT vector plus TY vector. Let's name this as equation 1. In triangle XTZ, XZ vector is equal to XT vector plus TZ vector. This is equation 2. 1 plus 2 gives XY vector plus XZ vector is equal to XT vector plus TY vector plus XT vector plus TZ vector. So we get 2XT vector. Now this TY and TZ, these two are equal in magnitude because T is the midpoint of YZ, but TY and TZ are opposite in direction. So I can change either one of these. TZ has been written as TY minus TY. So it becomes 2 times XT vector. So the option is B. Let's get back with another case study question tomorrow. Thank you all.